Hello, so today I will be proving the derivative of cos x and sin x. So first we're going to be starting with the proof of derivative of sin x. Alright, so first you want to write it as a function of f at x equals sin x. And to prove this, we're going to use the Newton's quotient. We have trig identities here. Trig ID. And we are also going to use a graphing software. Okay, so first things first, of the Newton's quotient, we want to make this f at x plus h, which will equal sine of x plus h. Then we're going to go over to our trig identities and see that here sine of x plus y, which is the same as sine of x plus h, is equal to sine x times cos y plus cos x times sine y. So we're going to make f at x plus h equal to sine x cos h plus cos x sine h. We have, now what we're going to do is subtract sine x from this, Newton's quotient, so we're going to get dy over dx as the limit approaches 0. We get f at x plus h minus f at x all over h. So what this is going to look like is, this is going to look like sine x cos h plus cos x sine h minus the sine x from here all over h. Now we're going to rewrite this to bring this over here because we have a sine x here, so we're going to subtract that. Then h approaches 0, sine x cos h minus sine x plus cos x sine h all over h. And what we're going to want to do in the next step is separate these into their own limits. Okay, so we're going to have sine x cos h minus sine x all over h. And then we're also going to have this limit here of cos x sine h all over h. Next, what we're going to want to do here is we're going to want to common factor the sine x out of this. Alright, so what we're going to get is lim sine x times cos h minus 1 all over h. And then we get, sorry, that should be a plus here. And then the limit of the same thing. We're just going to, okay. Next, what we're going to want to do is the terms with the x variable in it. We're just going to want to shoot these in front of the limit here. So we're going to have sine x, which is 0, all over h, plus cos x is the limit, h approaches 0, is sine h over h. Next, what we're going to look for is we're going to graph these. Graph. So if we look at my graphing calculator here, I have the graph of both of these. Okay. The first one in blue being the cos x minus 1 or cos h minus 1 all divided by h. So if we look at the blue graph here, we're going to trace it, and as h, or as x approaches 0, y equals 0. So we can see that right here. Okay, and next we're going to look at the second graph, and we're going to write that down here. Let me write that down quickly. So this is going to be 0. Okay, now we're going to look at the second graph, which is sine h divided by h. And we look here, we're going to trace the second one. So we're tracing in red. Trace. Here we go. And we can see as x approaches 0, y will equal 1. So this will equal 1. Okay. So now we know that this is equal to 0, this is equal to 1. So we have sine x times 0 plus cos x times 1. This is 0. This is cos x. Therefore, sine x, the derivative, is equal to cos x. All right, so next we're going to be proving proof of the derivative of cos x. All right. So first we're going to use this first ID at the bottom here, this transformation ID. And we see that cos x is equal to sine of pi over 2 minus x. All right. Next, what we're going to want to do is we're going to use some chain rule. So we're going to find the derivative of the outside, which will be this, times the derivative of the inside, which will be in the brackets here. Okay, we already know that the derivative of sine x will be cos x. Okay, and we'll just get the derivative of this later. So dy over dx equals, so derivative of the outside, cos x, cos of whatever's in the brackets. So pi over 2 minus x. And then we're going to multiply that by what is in the brackets here, the derivative of it. And we know this will be 0, this will be 1, and then we have the negative, so this will be negative 1. Okay, and then what we're going to do here is we're going to use another trig ID for this. So if you look at this second ID here, we see cos of pi over 2 minus x equals sine x. So we're going to transform this into sine x. So this is equal to sine x. Okay, so we'll say sine x times negative 1. And of course, this will equal, if we multiply the negative 1 in, negative sine x. Therefore, the derivative of cos x is negative sine x. Okay, so I'll pull up these two sheets. So we have the proof of the derivative of sine x, proof of the derivative of cos x. We used the proof of the derivative of sine x to help us here. So it's good to know this one first. This one's a little longer, of course. And just a reminder, for this one, we use Newton's quotient, one trig identity, and graphing software here. And then for this one, we used the proof of the derivative of sine x. We used two trig identities. And yes. All right, thank you.